or lesson 2.5, as it were. Today we're going to get into functions. We talked a little bit about what a function was in the past, but we're going to go into some more detail today. So a function has three parts. It has the input. Remember, I related it to a machine previously. A function is like a machine. You put something into it, and then some stuff gets done, and you have something else that comes out. It comes out differently than it went in. So the input is usually what we would call the x, and then the relationship is if it's being multiplied or added or having whatever done to it, and that's the machine part of it. And then the output would be the y, and we usually write it a little bit differently. We would write f of x. So this f is the name of the function. This is function f. X is the input, okay? And so f of x is going to be the output. F is the function, x is the input. F of x is the output. Well, what is the function? What is the relationship? In this case, we're adding 2 to whatever is input, okay? So let's look at this in a chart. Here we have the relationship listed out, x plus 2, okay? Put all of that in. Now let's look at some different inputs. If we have 2 plus 2, 4 plus 2, 5 plus 2, or 10 plus 2, we're going to get these various outputs. 2 plus 2 is 4, 4 plus 2 is 6, 5 plus 2 is 7, 10 plus 2 is 12. So it's simply a different way to write some types of equations. That's one way of looking at it. But these types of equations are special because for every input, you can only have one output. So you can't put the number 2 in and get two different answers, 4 and 6. You can only get one answer for every input. So here we have some, I guess you could call them Venn diagrams. We have the inputs on the left and the outputs on the right. And as you can see, for every input, it traces to an output, okay? This is a one-to-one, one input, one output, okay? So we can see in all of these, if it's a function, it will only have one output. If for some reason one input has more than one output, it is not considered a function. All right. So here's a function. These are names. We input Amy and we get Joe. We input Sarah and our output is Bob. We input Liz and our output is Dan. So both of these are definitely functions. Here we have 3, input 3, output 5, input 6, output 5. Well, that's strange. We have 2 different inputs and then we got the same output. Well, that's okay in a function. Remember, our rule was for every one input, it can only have one output. It doesn't say anything about different inputs having the same output. So that's still going to be okay. 9 is output 15, 21 output 10. So this one is a function. All right, so this last one, 2 outputs 2, 4 outputs 4, 6 outputs 4, so far so good, and 8 outputs, wait, 8 outputs 6 and 8? This one is not a function, okay? So a function will relate. It's a relationship, a machine. It relates each element of an input set with exactly one element of an output set. Functions many times are written as equations, but not all equations are going to be functions. Here's one that, again, when you have it in a Venn diagram type of way, you can see easily that it is not a function because we have one input going to 2 outputs, so that's not allowed. But again, 2 inputs going to 1 output, that is okay. It's called a many-to-one function, okay? So here we have some domain and range. Now, we've looked at domain and range in our vocabulary to this unit, to unit 2. And so here we have our inputs are X and our outputs are Y. Well, input has a special name. It's called the domain, and outputs have a special name. It's range. Well, D comes before R in the alphabet and X comes before Y in the alphabet. So it's easy to remember. You put the D, domain, with the X, the input, and the range, the Y, with the output. They're all in alphabetical order. So if you just remember that, you should never get it mixed up. Here's a function. The function of x is x squared. So for every input, we have exactly one output. -4 has an output of 16. 0 has an output of 0. 1 has an output of 1, 3, 9, 4, 16. So you don't have to draw this circle with arrows every time. You can look at it in a chart and tell whether or not it's a function. Let's look at this one. Here we have the function y squared or the equation y squared equals x plus 5. And you can see the inputs. 4 gives us an output of -3, but 4 also gives us the output of 3. Well, that's one input, and it produces two different outputs, a positive and a negative. As you can see, it's easy to identify when something's not a function because you'll have repeated numbers here in the chart of the input. So some 4s, some 20s. Sometimes they won't be right next to each other. If you're looking at a chart of inputs and outputs, sometimes they'll be spaced apart, so it's harder to notice that you have duplicates. But if you have duplicates in the input of a chart of an equation for the x's and y's, then you know this is not a function. All right, so here's some other vocabulary that you may come across when working with functions. We have, remember, your input can be any letter. In this case, we chose x, t, or theta. And your input can be called the domain. Remember, we talked about that. Domain elements, independent variable, because this doesn't depend on anything. It's also known as the argument. The relationship, the machine that the variable or the number is going to go through, sometimes it's called it maps to. So the domain maps to the range. And the range, remember, is written with the name of the function and then the variable. So this is the output, f of x or g of theta. Again, this is called the range. It can also be called the image or the range elements, the dependent variable, because whatever the output is, it depends on what the input is. It's also known as the value of the function. So you can graph all functions. And when you graph functions, you're going to have to know how to, as with any graph, figure out an ordered pair. So the ordered pair, the input is the first number and the output is the second number. And it always is in this order. So it works for ordered pair. Here's an example of an input of x and an output of f of x, which traditionally we would call y. That's our usual way of writing on a graph, x and y. In this case, it's x and f of x. So here is a graph we have. And one of the things we want to talk about today is we have here, the function can be defined as a set of ordered pairs. So even if you don't know the relationship between these, you can know the function based on its set. So 2, 4, we would have a point right there. 3, 5, point right there. 7, 1, 2, 3. Okay, so this is a function. It says 2 is related to 4, 3 is related to 5, and 7 is related to 3. Okay, functions aren't always going to be continuous lines. Sometimes they'll be disjointed. All right, also notice that the domain 2, 3, 7, these first numbers 2, 3, and 7 are the input values, and the range 4, 5, and 3 are the output values. And when you say them, you say the input first and the output last. One way you can tell that this is a function, even with it being discriminant or just dots, points on the graph, is because it passes something we call a straight line test. And so whenever you have something that is graphed or an equation that is graphed, you can take a pen or a pencil and go across it. And if at any point the pen or the pencil or any straight line crosses more than 2 points at once, then it is not a function. As you can see, at any time, if I were to have a slider and be able to slide this vertical line back and forth, it would only ever cross 1 point at any given time. And so that's one way you can tell that this is going to be a function. So here's an example of the vertical line test on the graph that we just talked about. So we have here an equation, y equals x squared. I happen to know that x squared has it goes through the origin point. And then say, for example, if you were to put in 1, you'd get 1 out of it. If you were to put in 2, you'd get 4 out of it. If you were to put in 4, you'd get 16. 3 is a 9. And then you also, if you put in -2, etc., you would be able to move up this way as well. So it's going to look something like that. And if I were to take, I didn't go through this point, but it should have. If I were to take my pen, my vertical line, and go across it, you'd see that I would never, ever go across more than one point on this line at any given time. So that one is a function. All right. So our next one we have here is y equals 2. Now this is a special kind of line. Our last line that we looked at was called a parabola. Anything that is an arc, whether it's facing upwards or downwards, is considered a parabola. And it is a function, a parabolic. I don't know if that's the correct phrasing, but it's a function that produces the shape of a parabola in a graph. Now y equals 2, this is going to be a straight line graph. So if y equals 2, it doesn't matter what x is. So if we put in 1, well, y equals 2. Okay. If we put in 2, y equals 2. If we put in 4, y equals 4. Well, how does this work? I don't see any x's. Well, it's really y equals 0x plus 2. So anything we put in, 8 times 0 is 0 plus 2. There you go. 6 times 0 is 0 plus 2. -4 times 0 is 0 plus 2. Okay. So y equals 2 is this horizontal line. Anytime you have y equaling a single number is a horizontal line. Now, is this a function? Okay, well, let's look. We have our pen. We're going to take it and do it across the graph. Does it ever cross the graph line in more than 1 point at any given time? No, it doesn't. So that is a function. Okay, let's keep going. X equals 2. Well, x equals 2. Let's look at this one. I knew what y equaled 2 was. X equals 2. That means x always has to be 2, no matter what y is. So instead of being a horizontal line, this is a vertical line. Now, if I were to take my pen and go across it, well, there's only one place where it ever crosses the line. And at that point, it definitely touches more than 1 point, because as my vertical line crosses this, it crosses an infinite number of points. So this one is not a function. So anytime you have x equals a single number, a constant, then you know that that one is not a function. Okay, moving on, we have y equals x. Okay, well, 0 equals 0. Here we go. All right, what if I put in 1? 1 is going to equal 1. Okay, and 2, put in 2 for x. Well, that means y is 2. What if I put in 4 for x? That equals 4. Okay, let's go to negative. What if I put in -6 for x? Well, that's going to get me -6 for y. I can already see my line taking shape. Well, this is a diagonal line, exactly cutting the plane in half. Okay. Now, our question is this a function or is this not a function? Well, if I take my vertical line test and put it across the graph, it never crosses the line in any point more than once. When you cross the line, you're not getting more than 1 point at any given time. So it is a function. All right. Ooh, y squared plus x squared equals 25. What on earth is that? That is a graph that is going to look like, okay, here comes my drawing skills, and they're not succeeding. It's supposed to be a circle. So this is a graph of a circle. My representation of a circle is not very good, but you get the idea. It's a circle. So now in this case, if I take my vertical line and I go across the graph, am I going to cross it in more than one point at any given time? Absolutely, I will. Just this one vertical line I drew alone, I'm going to cross this graph in 2 places. So that automatically rules that out. This is not a function. So we had function, function, not a function, function, not a function. So anytime you have a picture of a graph or you're able to graph it yourself, you can easily tell whether or not something is a function using the vertical line test. All right, so another way thing you need to know about functions is to evaluate the functions. It's the same thing as when you're substituting something for a variable, right? So when we evaluate k of x is 6x plus 100 for k of -5, that simply means we're going to take this -5 right here and input it wherever there's an x. This is the substitution that we're going to do. We're going to substitute -5 for x. So it's 6 times -5 plus 100. So 6 times -5 is -30 plus 100. Okay. -30 plus 100 is going to be 70. So how you write this, you don't say y equals, you don't say x equals. You say k of -5 equals 70. And that's the way you would write the answer when you're asked to evaluate a function for what you were asked to substitute in. You're going to write your answer this in place of normally you would have a y. All right, so evaluating functions. You can also evaluate it if you happen to know the output, but not the input. So here we're asked to evaluate h of t is -10t plus 6. Evaluate that when h of t is -44. So in this case, instead of asking to find h of a number, we don't know what that input is, but we happen to know what the output is. So in this case, what you do is you replace the -44 for the h of t here. So I'm going to rewrite this. -44 equals -10t plus 6. Okay. Subtract 6 on both sides. I'm going to get, oops. Let's see, if I subtract 6, it's actually going to go up. So 44 plus 6, 7, 8, 9, 10 is going to be -50 equals -10t. And now to get t by itself, I'm going to divide both sides by -10. And that's going to leave me with a +5 here because I've got 2 negatives. That's an even number. So that means that my answer is going to be positive. 50 divided by 10 is 5. These cancel out, and I've got t. So my answer is t equals 5 when h of t is -44. All right, so you can also evaluate the function when you are given it in graph form. And I'm sorry, my graph seems a little blurry here. The function f of x is graphed. We need to find f of -1. Well, remember, this right here is the x, f of x. So we find what the y is when our x is -1. So here's -1. Our x is 6. So f of -1 is 6. What's the input value of x for which f of x is 6? So in this case, they're giving us the y value or the f of x value, the output value. And we're being asked to find out what the x value or the input value is. Okay, so we need to find, okay, well, the output is 6 right here. Okay, here we have an input output value, right, of 6. Here we have it as well here. So there's a number of places where the output value is 6. Okay, so what is the input value for x for which f of x is 6? So it actually ends up being a set of -4, -1, and +4. Oops, curly brackets there. Close out my set. What is the input value other than 0 for which f of x equals 8? So if we go up to 8, we see one here. Oops. We see one here, but it says other than 0. So this one doesn't count. So we see one more right here. Now, in my function example that I'm giving you, it is also all of these, but we're just going to do the answer of the single number 1. Okay, so f of x equals 8, f of 1 equals 8. So we would write that f of +1, not -1. F of 1 is 8. All right. So hopefully that helps you to see a little bit of how to evaluate functions. Now let's get some practice in on some fun word problems. All right, so we're supposed to write a function using the appropriate notation for each situation below. All right, you bought a plant that is 5 inches tall. That seems like pertinent information. And you know that the plant will grow at a rate of 2 inches per week. Well, if it's growing, I'm going to say that that's going to get bigger. So I'm going to put a plus there. I think that's going to be a plus. Write a function for the height, h, of the plant after a certain number of weeks, w. Okay, so the function for the height, that tells me they want me to name this function h. And remember, the name of the function goes at the beginning, h, of the plant after a certain number of weeks. So we're not going to use x, we're going to use w. So this function is h of w. Okay, h of w is, now my plant started off at 5 inches tall. So no matter what, I'm going to always have 5 here. And it's going to grow at a rate of 2 inches per week. So 2, let's see. I know 2 is important, but let me draw my little plant here. Got a plant. This is 5 inches. And after week 1, it's 2 more inches. Week 2 is 2 more inches. And it's going to keep going. So it looks like it's 2 times the number of weeks added to however many 5 inches is. So I'm going to put 2w here. Let me see if that works. Let's see week 2. Okay, if I plug that in, 2 times 2 is 4 plus 5 is 9 inches. Let's see if that works out with my drawing here. 5, 6, 7, 8, 9. Okay, I think we've got the correct function here. H of w is 5 plus 2w. And we verified it by having our own little example right there. All right, so here we're going to sell some brownies at a bake sale for 75 cents each. That seems like it's important information. Write a function for the revenue, R, you've earned based on the number of brownies you've sold, B. So R, revenue based on brownies. R of B is, okay, only information I have here is 75 cents each. So I think it's just 75 cents times the number of brownies I've sold, right? 0.75B. If I sold 2 brownies, I'm making $1.50. 75 and 75 is $1.50. Yep, that's my function. R of B is 0.75B. All right, evaluate the function f of x is 7x minus 3 for each given value. Now I know you already know how to do this, so I want you to pause the video, substitute each number here for the input and where the x is, and give me the correct output. And pause it when you're ready to review. All right, so let's start with f of 3. 7 times 3 minus 3. 7 times 3 is 18, isn't it? No, that doesn't make sense. Oh, the answer is 18. 7 times 3 is 21 minus 3, which is 18. So f of 3 is 18. All right, gotta learn how to read my notes here. All right, so let's plug in f of negative 2. So 7 times negative 2, I suggest always putting in parentheses here because then we can just plug this into our calculator. 7 times negative 2 minus 3. On your graphing calculator, if you're using a graphing calculator, sometimes there's a special plus or minus button for a positive or a negative symbol, or sometimes it's just a special negative symbol that you would be using instead of a minus sign. So you need to be familiar with your calculator. Okay, but 7 parentheses negative 2 minus 3, plug that into your calculator and you're going to get negative 17. So f of negative 2 is negative 17. All right, so let's look at f of 0. 7 times 0 minus 3. Plug that into your calculator and you're going to get negative 3. So f of 0 is negative 3. All right, last one here. F of negative 5. 7 times negative 5 minus 3. Plug that into your calculator. You're going to get negative 38. So f of negative 5 is negative 38. And that was all of our lesson on functions. We're going to be back to look at some linear functions in the next lesson. See you then.